All right, we got points, lines, and planes today. And just to kind of speed things up, I pre-wrote in a bunch of stuff here, so you didn't have to, listen to me write it all here. So, in geometry, there are three undefined terms. We call them points, lines, and planes. We can describe each of these in the following ways using geometric symbols. All right. Now, part of the reason we call them undefined terms, they're kind of hard to define. They're hard to put words to, but they're also kind of like the building blocks of geometry, meaning that everything else in geometry we can kind of link back to points, lines, or planes, and we can describe other things in geometry using points, lines, and planes. So these are, the building blocks essentially. So point, it's exactly what it sounds like. We say it has no dimension and it represents a location in space. By the way, if you need to pause to get something written down, feel free to do that. Maybe I can make things look a little bit prettier there. Usually it's represented by a dot or an intersection, like an intersection of two lines. Sometimes we'll name it by a capital letter. So some examples, you would see just like a point, you could say point A right there. Eventually we're going to talk about lines, something kind of like this here, and you could say, okay, that's point B right there. So those are just two examples. Next you have line, so we say that these have one dimension and extends forever in both directions. Represented with a line with opposite arrows, just like this right here, that's what it looks like. There's two different ways you can name it. One lowercase letter, and actually that should be lowercase cursive letter there. So let me fix that. So we'll use a little bit of cursive, and then also the most common way is probably just 2 points on the line. So this one right here, it should be a little L right there. My PDF had some weird symbol there. So anyways, we can say line L like that, cursive L. You can say line AB, and then we actually put the line above it, kind of like that, and then 2 arrowheads. And then also another way you could do it is line BA. But since those are both going in the same direction, it doesn't really matter on the order that you write them. Okay. Last one here, you have a plane. Plane has two dimensions and it extends in all directions forever. An example of a plane, like tying back to math, like in algebra, you use the Cartesian plane quite a bit. Your x and y axis there, so that's why we say it has two dimensions, and we assume it keeps going in all directions forever. The symbol for it, you can do a parallelogram looking thing as best you can. Okay, one capital cursive letter, and then any 3 non-collinear points. And we'll talk about what collinear means here in a second. Essentially, it just means points that are on the straight line. So 3 points that are not on a straight line, you can name it that way. That's probably the most common. So you can name this one here M, kind of like that, uppercase cursive. You don't really see that one as much. We'll see more often. We'll see like plain like ABC or something. You put a little parallelogram, or you can even do it in a different order. You could go like BAC. So order doesn't matter there as well. So we'll move on here. A couple more vocab words here. Collinear points. So those are points on the same line. Okay, so non-collinear points. That kind of follows after that. It's points not on the same line. Okay, so usually you'll have like a set of 3 or 4 points, and then you just decide if they're on the same line or not. We can look at pictures for that. Line segment, that's part of a line. Here's what makes a line segment different. It has 2 endpoints. So instead of going out left and right forever or up and down forever, it has 2 endpoints. All right, and then by definition, we say line segments also all the points in between. Okay, you got coplanar, which is kind of like collinear. It's points all in the same plane. And then non-coplanar, you got points not in the same plane. That got left off there. All right, couple laws of geometry. Through any 2 points, there exists exactly one straight line, at least. A line contains at least 2 points. So these are really similar. These are, in a way opposites of each other. Okay. Through any blank, there is exactly one plane. So and we're going to say 3 non-collinear points. I'll just abbreviate that. There's exactly one plane. So that kind of goes back to the definition of a plane right there. You're always going to have at least 3 non-collinear points. If you have 3 non-collinear points, you can make a plane through it. Okay, so then this is the opposite right here, this next one. So a plane contains 3 non-collinear points. Alright, this one's a little different. If 2 points lie in a plane, then the blank containing them lays in the plane. So if 2 points lie in a plane, then the line containing them also lays in the same plane. Okay. If 2 planes intersect, then their intersection is line. Okay, and then we actually draw out examples of that. There's another intersection one. I don't know if it comes up, but if you have 2 lines intersect, they intersect at a point. Okay. Here's a couple of weird theorems because you'll have some trait questions on some tests, so you want to be looking out for these here. There you go, make a straight line. So anyways, 2 points are always collinear, even if the line is not drawn. So we'll have pictures, and we'll have to determine if things are coplanar or collinear. And we're always going to assume if there's 2 points, you can draw a straight line through it when you're given 2 points. All right, 3 points are always coplanar, even if there's not a plane drawn through it as well. So those are kind of your big main things right there. Those are kind of the tricky ones there. All right, give 2 other names for the line PQ and then for the plane R. Okay, so guess we only have 2 blanks there, but anyways, PQ, here we are right there. So there's 2 different ways you can do it. You can just go change the order. So we'll say PQ, or QP. It's a different order, or you can use that cursive N in this case, which I kind of forget how to do an N. I think it's like this. So anyways, that's 2 different ways to do that. As far as plane R goes, we can say plane R, we can use 3, and then you want to use non-coplanar points, or non-collinear points. So we could use like VSP, or we could go plane, VPT or something like that. Just points that aren't necessarily on the same line. Okay, name 3 collinear points. So we're looking for 3 points that are on the same line. So, for example, you can't say S, P, and Q because they're not on one drawn line. All right, but obviously S, P, T are. So we can just say S, P, and T. You don't need to do anything special there. That's it. Name 4 coplanar points. So that would be, since this line right here, since those points lie on the line right there, you're good to go. And then you have that extra point V, so we can assume all of those are on the same plane. So we'll say S, P, T, and V. And that's kind of how you interpret some of that stuff. Now, don't forget these 2 main points up here. We can consider V and S to be collinear right there. And we can assume like S, P, and Q, even though there's not a plane drawn through them, you could have some type of plane kind of going up like that hits all of those points there. So those 3 points are coplanar right there, even though there's not anything drawn. So those are the kind of tricky ones, I guess, right there. Okay, so the first couple of defined terms that we talk about are line segments and rays, and we can define them because we kind of know what a line is, and then we can use points to talk about endpoints and that type of stuff there. So the line segment, I guess I should have filled this out before. That's all right. Segment. I'm going to abbreviate that. So line segment AB written as AB, and then you just put a little line above it with no arrowheads. Consists of, I guess, points A and B, and all points on AB that are between A and B. Alright, another name for line segment AB is line segment BA. Kind of like what we talked about, the order doesn't matter. So, as long as they're the same line, going in the same direction, order does not matter on that. Or line segment, I guess. Okay, so you also have rays, which we just talked about. Rays written as, you can say like AB, and then just one arrowhead. So direction is key here in this case. So that consists of the endpoint A and all points on the ray AB that lie on the same side of A as B. So that so a ray is kind of like this right here. So starting at A and then everything, I guess, to the right of A. That's what a ray is. Note that ray AB and then BA are different rays, right? The reason being is because they are going in opposite directions there. So you got to be kind of careful on that. A lot of people want to switch around the letters, and that's a common little error that people make at the very beginning of the class. Okay, if a point C lies between A and B, on line AB, between A and B, then CA and CB are blank. So let's draw that out there, because this picture right here, the first time I taught this, it kind of threw us off here. So I'm going to draw another thing here, another line going on here. So, okay, so we have A and B. We have this line A and B. And then apparently point C is in between A and B. So we'll put that right here. And that's why the picture kind of throws us off here. So so then CA and CB, we consider both of these here. CA and CB, we consider these opposite rays. So there's your picture for that right there. Okay. Alright, with the example 2 here, we got a couple of true or false things going on here. A couple of them are a little bit tricky. You can kind of see, I guess, in the font, the ones that we added in, just because they're a little bit trickier. So just kind of look up here. A, B, and C are collinear. Alright, so there's those 3 points right there. Since they actually are on that line right there, we're going to say that that is true. So that one's not too bad. Apparently we have this as a line. Line EF is perpendicular to line M. So here's EF right here. Here's line M. And since we have this little box right here between them, that's the implied signal, or symbol, I guess I should say, for a perpendicular. So that one's going to be true. Alright, let's look here. We got line BC. So that's this line right here, and just because it's BC, it's every point on that line. So that line going forever, and then apparently is that perpendicular to plane R. And, you know, here's your plane R right here. And I don't see a symbol between that. We'd probably need to see something a little bit more like this right here between that. So I'm going to say that one right there is going to be false. Okay, we have EF, line EF, I guess I should say, line EF, and then AC intersect at point B right there, and that's where they do indeed intersect, and there's a point there for that, so that one's pretty straightforward, that's true. We have line M, let's find that again, here we are, line M, and then AB, and apparently, sorry, that's my phone going off, apparently they intersect and are perpendicular. That's what that's asking for there. We would need to see, once again, like a little box symbol between those two lines right there. So that one's actually going to be false in this case. Okay, points B, C, and X are collinear. So here's point B, C, and X. Since those are not drawn on the same line, we're going to put false for that one. We would need to see one single line drawn through those, and there's really not even a way you can draw a line through those points there, so that one's going to be false. Okay, and then, oh, whoops, I'm getting ahead of myself. B, C, and E are coplanar. So there's B, C, and E. Are those on the same plane? They are. They are on this plane right here, plane R. So I'm going to say that is true right there. Okay, you got the intersection of two planes here, plane S and plane R. So that's, your two big planes right there. And they intersect here at this line. Usually two planes, if they intersect at all, they'll intersect at a line. And that is line M, so that is true right there. Okay, and then I guess these ones here that I added in. So we have A, C, E, and then X. So let's find all those. A, C, E, and then X. Are those coplanar? I think they're on, 3 of these points are on plane S. But then since you have that one point E, that looks like it's on R right there. These are not going to be coplanar right there, so that'll be false. Okay. Kind of a tricky one here. I kind of like this one. I'm going to put a star next to it. A and X are collinear. This is one of the few weird cases right here. Okay, and I think there's that theorem somewhere. I think we've already seen it, where it says any 2 points are collinear no matter what. So even though there's not a technical line drawn through these here, we're always going to assume 2 points always collinear. So if you want to add yourself that little note again, we have it somewhere else in our notes, but we can also just add 2 points are always collinear, no matter what. Okay, and then by that same argument too, I think we saw the theorem saying 3 points are always coplanar as well. I don't think we see that example. K is another kind of weird one right here. So I think put another star next to this here. So we have A, B, and C. And then also E right here are coplanar. And this one actually, so it looks like A, B, and C are all on plane S, and then E is on plane R. But there's actually an imaginary plane that you could draw through all 3 of those points there at the bottom and point C. So if you were to like draw your own plane, you could say that those are coplanar right there. So this one, it's a tricky one. This one's true. And if you want to put like more specific reason here, it's because A, B, and C happen to be collinear. So it's kind of like you can only, maybe just only focus in on 2 of the points, and then your third point right there, E. So it's because A, B, and C, since those are all collinear, if you look here in the picture, they're all collinear, and then you have that 1 point off right there, E. That one's going to be coplanar. It's kind of like an imaginary plane. Kind of like how there is an imaginary line between A and X. There's an imaginary plane that can hit all of those points right there. So that one's a little tricky there. So I'll write a little note here. I'll say because A, B, and C are collinear. That's why that is true right there. Segments in rays are blank if they are on the same line, so I guess we can say collinear. Opposite rays are, by definition, always collinear. I'm not sure where my C went. Lines and segments and rays are blank if they are in the same plane, so that would be coplanar. Most of that's pretty straightforward, nothing wild there. 2 or more geometric figures blank if they have 1 or more points in common. So this is the fancy definition for intersection. And actually, I think here with the grammar, I think that's intersect. Yeah, they intersect. The intersection of the 2 figures is the set of points that the figures have in common. So here you got an example of 2 lines intersecting. We already kind of talked about that. It's at a point. 2 planes intersecting. It's got to be a line. Okay, the intersection. Okay, we just talked about that. Yeah, 2 lines is a point. Intersection of two planes is a line. So now we're going to actually practice drawing some of this stuff. And, some of this is kind of tricky, and this is an art, but we need to, try the best we can as far as drawing this up. So what does the intersection of three planes look like? Actually, there's two main ways you can draw this here. So usually when I'm teaching this live in class, I point up at the corner of one of the corners in the, the top of the ceiling. So imagine you have like maybe your ceiling kind of like this. Well, here, let me draw it like this. Let's think about a box. Think about the top of a box, the side of a box, and then the front of a box. So, like a tissue box or something like that. These three planes right here intersect at that point. We can call it like point A or whatever you want right there. So that would be an example. Another example I like to think about like a book. Imagine you're holding a book and you've kind of fan out some of the pages. It's not the best picture here. It's kind of hard to draw things perfectly on Notability. So imagine you open up the covers and then you got a couple pages there. So these three planes intersect in this line right here. We could call it, line A, B. And be careful, some teachers get kind of picky, if you're going to draw this, they want to see that they intersect at a point, so make sure you, write out your point or write out your line, A, B. So be kind of careful on that. Make sure you verify with your teacher on that. Oh, is there another possible intersection for three planes? If so, sketch it. So I kind of accidentally already did that. So let's see if we can move it down here to where it belongs. So that's two different ways you can do three planes there. Sketch two planes that do not intersect. That's probably what I would do. I would just draw two parallelograms that look like they're parallel to each other. So that's about the best way you can do it. Some of this stuff is going to be kind of sketchy. It's not going to look super great, but that's what I would do. Two planes, just make them look like they're parallel to each other. Sketch two planes that intersect in a line. So you could use the picture we used above, like the book. You could do like what we saw earlier on that previous example. We have like let's see, I don't know, something kind of like this here. So that was kind of like the example we saw above, or you could do like the book example. So and feel free to pause if you need to get your sketches. Sketch a line that intersects a plane at a point. So this is kind of how I like to do these here. I just imagine a piece of paper and then just stick in like a pen or something right through the paper. Now, the way some people do the part of the line where you can't see because a plane's covering it, they do like a little dotted line. So that's kind of like the best way, I guess, to draw that right there. We can call this point A since it intersects at a point. Well, what do we got here? Sketch a line that lies in a plane. Once you do a couple sketches, that probably won't be that bad. Just draw a line literally inside of a plane, call it AB. Good to go. You can use whatever letters you want as well. So I think that is it here for today. So a little bit of a shorter one.